welcome you all in this lecture on mechatronics. Today we are going to see the hydraulic and pneumatic actuators. You see any actuator in a mechatronic system works when the actuator receives a control action from the microprocessor or microcontroller, whatever is being used. So, that control action has to be converted into some movable action, and that could be done by either of the actuators, which we call actuators. And today we are going to discuss about hydraulic and the pneumatic actuators. So, as I said, actuators are elements of control system responsible for transforming the output of your microprocessor or microcontroller into the control system or control system into a control action on a machine or device. For example, I can take the electrical output of a controller has to be transformed into, say, linear motion to move a load or to do some control action, say operating of a certain valve of the hydraulic system or say some valve of the pneumatic system. So, this is where these actuators are used. Now, before we proceed, let us try to understand the characteristic of pneumatic and the hydraulic signals. The pneumatic signals are you see pneumatic signals used actually pneumatic devices used air as the medium. So, they are used to control final control elements even when the control signal is electrical. So, although the control signal is electrical, which is coming from the microprocessor or microcontroller, but the final control element could be the pneumatic signal, and these signals could be used to actuate large valve and other high power control devices. But the drawback of the pneumatic signals is that the air which is being used as the medium, it is compressible. So, the compressibility of air is a problem. Now, coming to the hydraulic signals, these are used for the high power control devices. As we know that hydraulic signals are powerful, but these devices comes with many of the other peripheral things. So, because of that they are more expensive, and these hydraulic signals are achieved by devices which used the oil. So, there are hazard associated with the oil leak. Now, let us look at the difference between the pneumatic and the hydraulics. As we know that the pneumatics we used air as the working fluid, whereas in case of hydraulics we used the oil or the mixture of water oil emulsion is used as the working fluid. So, the fluid power denotes the use of pressurized fluid to drive the linear or rotary actuators, and this subject can be broadly divided in two fields, pneumatic and hydraulics, as I said. In case of pneumatic, the working fluid is the compressed air, and in case of hydraulics it is oil or it is the water oil emulsion. And the two fields have great deal in common, but there are also some basic differences between them. Let us see what are the differences between the two that is hydraulic and pneumatic systems. Okay. So, first of all let us look at the pressure level. In industrial pneumatic circuit, the pressure ranges from 5 bar to 10 bar, okay. Whereas, in hydraulic circuit commonly used pressure is up to say 200 bar or even much higher. So, you can see the difference, okay. You can see the difference. So, pneumatic devices are used for the they are the lower pressure devices, whereas the hydraulic devices are the higher pressure devices. Now, actuating forces, okay. Because of relatively low air pressure used, pneumatic actuators can produce only low or medium size forces, okay. Whereas, hydraulic actuators are used for very high load, okay. And if we look at the cost wise how they differ. So, the hydraulic cylinders and valves can cost you say 5 to 10 times more than the similar type of the pneumatic elements. Now, let us look at about the transmission line. Okay. Why transmission line? Because we need to transfer these compressed air or the your liquid through the hydraulic devices. Okay. So, hydraulic transmission lines are usually made of metal tubing needed to withstand the high working pressure and to avoid the leaks. In pneumatic, we use the flexible plastic tubing is used, and the fitting can be usually be done by the hands, okay. And you see hydraulic in hydraulic system your working fluid is precious, costly, okay. So, unlike the pneumatic system where we can allow the air to escape to the atmosphere, in the hydraulic system we cannot allow the oil to escape to atmosphere, okay. So, we need the return line to return the oil from each cylinder back into the reservoir. Then about speed control. Because of the compressibility of air, it is difficult to control the speed of pneumatic cylinders or motors accurately. So, there is a speed control problem with the pneumatic devices because of compressibility of the air, okay. So, whenever constant actuator speed are required despite sudden load changes, we go for the hydraulic system, okay. Fine. What about actuation speed? Since compressed air expands very quickly, the piston velocities in pneumatic cylinder are usually very high, and they provide the actuating valves and air supply tubing, or if they are properly sized, okay. And so, they do it quickly. Whereas, in case of hydraulic cylinder, piston velocity is usually low, being determined by the flow rate of the pump. Coming to the power source. In hydraulic system, we use the constant displacement pumps are used, so that the oil flow rate is constant regardless of the load pressure, okay. The pump does not produce pressure, but rather a constant flow. The pressure developed in the system depends on the opposing load. Whereas, the situation is exactly opposite in case of pneumatic system. In case of pneumatic system, a pressure regulator connected at the compressor receiver outlet keeps the air pressure in essentially constant, okay. Whereas, the air flow rate into the given cylinder is determined by the load. So, in case of the pneumatic one, the air flow rate is determined by the load, whereas in case of hydraulic one, the pressure developed in the system is determined by the load. Now, let us look at what are the various components of hydraulic and pneumatic system. Okay, because we are going to use these as a an actuating device in our mechatronic system. Okay. So, what are the essential component? Okay. So, as I said, there are many things common between the hydraulic and pneumatic devices. Alright. So, these components could be say the power supply, directional control valves, pressure control valves, cylinders, and the process control valve. So, these are the various components. Let us look at one by one. So, first of all we will be looking at the hydraulic power supply. Now, in the hydraulic power supply as I said, we are using the oil. So, there is a sump where oil is there. Now, this oil is pumped with the help of a pump, and this pump is actuated by a motor. Now, oil from the pump goes to a non-return valve, okay, so that oil does not come back to the sump from this side, okay, and then it goes to a pressure release valve over here in order to release the excess of pressure, okay, and then it goes to the accumulator, okay, and whatever oil is remaining or returning, that return is through the return side, and that oil can come back to the sump, okay, and then this cycle can be repeated, okay. In the pressure release valve also the oil is brought back to the oil sump, okay. So, here in the hydraulic system, the pressurized oil is provided by the pump driven by the electric motor, okay. The pump oil from sump through non-return valve, and it is sent to the accumulator to the system, from which it returns to the sump. Now, what is this accumulator? Okay. So, this accumulator is a device to smooth out short term fluctuation in the output oil pressure. And how this is done? So, this device has got a basically there is a bladder on which a gas is there, okay, and there is a gas charging valve through which this gas can be charged, and there is a hydraulic fluid over here. Now, what happens if the pressure here increases? Okay. So, if the pressure increases, what will happen? This bladder will shrink, okay. So, the bladder volume will decrease, and if the bladder volume decreases, what will happen? The liquid will be occupying more and more space, okay. So, the liquid volume will be increasing, and this will return your fall in the pressure, okay. This will return your fall in the pressure, okay. And if there is a reverse situation, that is if your pressure is decreasing, alright, then what will happen? If pressure is decreasing, your bladder will be expanding more, okay. So, so your gas volume will be increasing, okay, and if your gas volume is increasing, then naturally the liquid volume is going to decrease, and if liquid volume is going to decrease, your pressure is going to increase. So, this way your accumulator, okay, smooth out the short term fluctuation in the output oil pressure. So, hydraulic pumps are driven by electric motor or internal combustion engine, that could be there, and fluid pressure generated by the pump in heavy equipments are say from 6.89 megapascal to around 20.7 megapascal. And when we are selecting the hydraulic fluid for our mechatronic system, the selection criteria has to be based on its lubrication property, that is it should be good lubricant, it should be corrosive resistance, it should not corrode to the component of the hydraulic actuation system, and it should be incompressible, so that it can provide the rapid response, okay, unlike the pneumatic system where we have the we use the air which is compressible. Most hydraulic pump are actuated by the positive displacement devices, okay. That is, they deliver a fixed volume of liquid in the each cycle, and there are three main types of pumps are used. These are the gear pump, vane pump and the piston pumps, okay. So, in the gear pump basically there are two gears basically, okay. So, the two gears are there like this, and these gears are in mesh basically, okay. So, something like this they are there, this device is there in a casing, okay, and you have the input from here and you have the output from here, and it compresses and displaces the liquid. Okay. Similarly, the vane pump has got vanes basically, which when they move they displace the liquid, and likewise with the piston pump. Now, let us look at the pneumatic power supply. So, the pneumatic power supply looks like something this. Okay. So, you have to take in the air, okay. So, there is a filter to remove the dirt and other thing, and there is a silencer being used in order to remove the noise, and then there is a compressor to compress it, okay. So, you have a motor, okay, to drive the compressor. So, if there is excess pressure, you have the pressure release valve from where you can control the pressure, and then this air because it is compressed in the compressor, it gets heated, okay. So, you need a cooler to cool down that air, and then the filter and water trap, if some water moisture of the air gets condensed, so that moisture can be removed in the filter and water trap, and then it goes to the air receiver, and then you have a supply. So, this is our pneumatic power supply, okay. And this air receiver actually increases the volume of air in the system and smoothen out any short term pressure fluctuations. Commonly used air compressors are one in which successive volume of air are isolated and then compressed, okay. These are actually the reciprocating compressor, rotary vane compressor and the screw compressor, okay. And the reciprocating compressor principle is again very simple, as you can see that we have some cylinder and piston arrangement basically, and you have the inlet port and you have the exhaust port, and air comes in and then it is compressed by the piston and then it is delivered, okay. So, the same principle which is used in your IC engines. Then the other element is the directional control valves, okay. So, as the name indicates, they direct the fluid flow through a system, okay, and they are either completely open or closed, or what we call it as the on off devices, okay. So, these are of two types basically, the spool valve and the poppet valve, okay. So, let us see the spool valve. So, this figure illustrate you the spool valve basically. So, here there are three ports basically, port 1, port 2, port 3. Okay. So, through port 1 there is a air supply, and through port 3 there is vent to the atmosphere, and through port 2 the pressure is given to the your device wherever you want to use it. Okay. So, this spool has got say these two pistons are there which constitute the spool, and you have a shaft. So, in this condition you see that this inlet valve is open, and this supplied to the air is supplied to the device this way, okay. And in this configuration it is exhausted basically. So, this goes from your device to the vent to the atmosphere. So, this way it is there. Now, poppet valve, if we talk about poppet valve, they are normally closed, Okay. So, this is how the puppet valve configuration is. So, you have this device here, there is a ball over here, okay, and you have a spring. This is the pressure supply port and this is the system side port. Okay. So, if button is not pressed, so you can see that this is there in a closed position because of this spring. So, spring keeps this valve closed position. Okay. So, there are two position here, one is with button pressed, that is on. So, if you press the button, then what will happen, this spring will be placed and the pressure supply port will be connected here to the system side. Okay. So, one with the button pressed, that is on position, and one with not pressed, this is the off position. So, this is your off position and this is your on position. Now, in a circuit, hydraulic circuit, there could be many type of valves being used. Okay. So, to represent the action, okay, we use the valve symbols, okay, and these valve symbols basically say we in these valve symbols we indicate the flow path like this, and if the flow is shut off then it is indicated like this, and this configuration indicates the initial connections. And there is a standard port numbering or a letter according to their function, say 1 or P is used for the pressure supply, 3 or T is used for hydraulic return port, say 3 or 5 or RRS is used for pneumatic exhaust port, and 2 or 5 or B or A are used for the output port, as I have shown you over here. So, this 2 is used for the output, 1 is used for the input and 3 is used for the exhaust. Okay? I hope it is clear. Now, there are various valve actuation symbols which are used basically. Okay. So, this is the symbol for the push button, this is the symbol for plunger. So, here it looks like a button. So, if this symbol is there, it means that the valve actuation is through push button, this is valve actuation through plunger, this is for using a lever, this is using a roller, this is by a pedal shape is here, okay, and by application of pneumatic pressure this is indicated, and if your spring is here shown here, it means that it is actuated by spring, and if it is shown like this, then it means that it is actuated by a solenoid. Okay. I will discuss about solenoid when we will talk about the electrical actuation systems. Now, for the 2 by 2 way puppet valve actuation symbol, this is the 2 by 2 puppet valve which we have seen. Okay. It has a pressure supply port, and it has the here the port number 2 which is connected to the application side. Okay. And you see that this valve has how many? It has how many ports? It has 2 ports. Okay. So, these are the 2 ports. So, in the 2 by 2 some symbols, first symbol actually tells you the number of ports, okay, and the second symbol tells you the number of positions. So, what are the number of positions here? The first position is the when there is a communication between say inlet and outlet, and the second is when there is no communication. Okay. So, these are the off position being indicated. So, there are 2 positions, number of position, and there are 2 ports. Okay. So, we have the inlet port and we have the application port where that valve is communicating with the device. Okay. And you see, with the help of this spring, okay, when this spring is in action, the valve is closed. That is why here towards the spring side we are seeing this symbol. Okay. And when we are pressing this, okay, button, So, in the button side, if we are pressing, there is a communication and the liquid flows like this. Okay. So, for that purpose, in this, when there is a communication between 1 and 2, we are indicating it towards that button side. Okay. So, this is the nomenclature which is used to indicate in your drawings. Now, let us look at solenoid operated spool valve. Okay. So, I have this spool valve, okay, this is the rod and these are the pistons, okay, and this is actuated by the solenoid over here. Okay. So, there is a soft iron core and you have a solenoid. As I said, I will be talking about this solenoid in my electrical actuation devices lecture. Okay. And there is a return spring here to keep spool in this position. So, in this position you see this is port 1, that is the pressure supply port, this is the port 2, that is the output port, and this is the port 3 or the exhaust port. Okay. So, in this one, in this device, how many ports are there? 3 ports. Okay. So, we have the 3 ports in the symbol I am talking about 1, 2 and 3. These are the 3 ports. Okay. And this is one operation where the pressure supply is communicating with the output port, and the other one and this one is activated by spring. So, when the spring is actuated, there is communication between 1 and 2. So, we are seeing this thing, okay, and the third is closed, third is not used. So, this is how it is seen. Now, when you actuate this solenoid, okay, so what will happen? This iron core will move. Okay. So, in that due to this motion, this is the position which will be getting, and 2 port starts communicating with port number 3, okay, this way. So, you have the communication this way. I have explained this in my earlier slide also. Now, this actuation has been done with the help of solenoid. So, I have a symbol of solenoid over here, and in this one, who is communicating with what? So, 2 is communicating with 3. Okay. So, this is the 2 port and this is the 3 port. So, the 2 is communicating with 3 and 1 is closed. So, 1 is over here. Okay. So, I hope with this you are able to understand how we are representing this 3 port 2 position valve. Then there are these valves can have various applications such as pneumatic lift system, and in this pneumatic system you could have a load here and you could have a cylinder piston type of arrangement say over here, and we can use the 2 push 2 by 2 valve can be used. Okay. So, with the help of spring, in the spring these 2 valves are when your spring is acting, these 2 valves are not communicating, okay, and when you push that button you are going to have the liquid flow taking place here, and this will be going up. Okay. And when you are switching this button down, okay, then in this condition your liquid will be moving in the opposite direction. Okay. So, this is how your this thing is going to work. Then there are pilot operated valves. Okay. Say force required to move the balls or a shuttle in a valve is often too large many times, okay, for manual or solenoid operation. So, to operate a valve we require another valve. Okay. So, that thing can be done over here. Okay. So, to overcome this problem, pilot operated system is used where one valve is used to control the other valve. Okay. So, the pilot operated valve is a small capacity valve and it can be operated manually or by a solenoid, okay, and it allows the main valve to be operated by the system pressure. Okay. So, for example, in this figure you can say that this is the pilot operated 4/2 valve, that is there are 4 ports here, okay, and there are 2 positions. So, one is this position, okay, and second one is the another position. So, when spring is acting, okay, in this position there is a communication between this and this port, whereas this and this port are closed, and when you are applying a solenoid there is communication over here and air is being supplied, whereas these and these are closed, okay, and this is the pneumatic signal which is going to your other valve. Then there are directional control valves, okay, and they allow free flow can occur in only one direction. For example, you see this arrangement here, no flow is possible in this direction because this ball is going to block any flow, and this ball is kept in this position with the help of this spring. Whereas, the flow is possible in this direction because if flow will be taking place, this ball will be pressed because of the pressure from the flow side. Okay. So, this direction flow is possible and this direction flow is not possible. Okay. So, this is represented in the symbolic form like this direction flow is there, this direction flow is not there, and this is the symbol for representing your ball. Then there are pressure control valves which are used in these systems. Okay. So, there are 3 principal types are there. One is the pressure regulating valve, and they regulate operating pressure and maintain a constant value. Okay. So, here the system basically consists of something like this. You have a system pressure here, if though your pressure exceeds, this ball is pressed and of course, whatever your working fluid is there that is released. Okay. And you setting of the pressure, at what pressure it should be released, that can be done with the help of this adjustable support. Then we have the pressure limiting valve, which these, as the name indicates, they are basically the safety devices, okay, and they limit the pressure, and they limit pressure below some safe value, and they valve open and vent to atmosphere or back to the sump. Okay. So, here is the system pressure side, this ball is kept in this position with the help of this spring, and so if there is a excess pressure, okay, then this is how it is vented. Okay. So, you can see the system pressure, spring is there, this is the symbol, there is a communication from this side to the vent side, this is your flow direction, and this is your symbol for vent. Okay. So, this is the condition when there is a that is venting is not there, it is not vented. And there are pressure sequence valve, these valves can be used to sense the pressure of an external line and give a signal when it reaches the preset value. Okay. Next let us see cylinders. Okay. So, hydraulic and pneumatic cylinders are an example of linear actuators. Okay. So, these mechanism are driven by there could be various mechanism which could be driven by hydraulic cylinder, and these cylinders could be either single acting or they could be double acting. Okay. Single acting means you have supply from one side, and in double acting you have supply from the both side of the piston. So, you could have supply from B side as well as supply from A side. So, this is what we call it as a double acting cylinder, and if supply is from only A side here, then this is called the single acting cylinder. Okay. And these are used in say hydraulic elevator or scissor jack or a cherry picker crane. And control of single actuated cylinders we can do, that is say here if we want to control this cylinder. Okay. So, when you have these are the two symbols which I am using, symbol for pressure source and symbol for the exhaust. Okay. So, when your spring is acting in this condition, you have the exhaust being taking place, and when your solenoid is acting, you have the communication. Okay. So, here this is this case when we supply the current basically. So, solenoid is acting and you have the pressure supply to the this cylinder. So, the input takes place, and when this is not there, then the spring acts basically and the exhaust takes place. Okay. Then we could have the control for the double acting cylinder also. Okay. So, in case of double acting cylinder, here say this solenoid is acting. So, in this case when this solenoid is acting, you have the flow from this one, okay, and exhaust takes place from here. Alright, and when this is solenoid is acting, in that case you have flow from this side and exhaust takes from this side. So, control pressure applied at each side of the piston. The difference in pressure between the two sides results in the motion of piston, and the piston is able to move in either direction along the cylinder as a result of the high pressure signal, and current through one solenoid causes the motion of the piston in one direction, while the current through the other solenoid reverses that direction. Okay. And the choice of the cylinder is determined by the force required to move the load and the your speed requirements. There could be cylinder sequencing operation also. This I am not going to talk much in detail. You can refer to Mechatronics by Bolton if you are further interested in how the cylinder sequencing could be done. Okay. So, say there could be two cylinder A and B, and we want to achieve the following operation. Say start button pressed, A, cylinder A extends. When A extends fully, then say B extends. When B extends fully, then say A retracts. When A retracts fully, then say B retracts. So, we could have a various combination of sequencing. Okay. So, this type of thing, extension represented by plus sign, retraction represented by negative sign here. So, these type of sequencing, cylinder sequencing also can be implemented with the help of hydraulic cylinder. Next, let us look at the process control valve. Okay. These are used to control the rate of fluid flow. Okay. And in this case basically what happens is there is a diaphragm, as you can see over here. This side is connected to the controller. There is a spring over here. This is atmospheric pressure this side, and there is low control pressure is there. Okay. So, basically in this case Pa is equal to Kx, this is the principle used. So, this is the force because of the pressure, and this is the spring force basically. Okay. So, the displacement of shaft is proportional to gauge pressure, and these are also called pneumatic diaphragm actuators. Okay. So, in case of high control pressure, you could have this type of configuration. And these type of devices actually, these type of devices, that is the process control valve, could be used to say operate certain valve, say diaphragm operated process control valve. Okay. So, here you can see that some fluid is going, and here is a valve basically, and this valve could be controlled with the help of this device from the controller. There are various types of valve bodies and plugs. This is a single seated normally open. So, this is a single seated, there is only one seat, and normally this is open condition. So, this is called single seated, normally open, and this is single seated and this is normally closed condition. So, normal condition, liquid cannot flow from this side to this side. Then we could have double seated, there are double seats, one seat here, another seat here. Okay. So, this is called double seated and normally open. Okay. So, normally open. So, the liquid can flow this way, alright, and this is the double seated, that is sitting here and here, and this is the normally closed configuration. There are various shapes of the valve for quick opening, linear contoured and equal percentage. Okay. So, these type of there, the quick opening valve flow rate change for small movement of the valve stem, as the name indicates, they are quick opening and these are used for the on off control. Then the linear contour type, they change of flow rate proportional to change in stem displacement. Okay. And so, you have the Q by Q max is equal to S by S max relationship applicable in the linear contour type, where S is the stem displacement and Q is the flow rate, and the equal percentage of flow rate occur for equal change in the valve stem position. Then we can also look at the control valve sizing. So, procedure to determine correct size of the valve body, the relationship for discharge is that is AV under root P by rho, where AV is the valve rate flow coefficient, delta P is the pressure drop across the valve, and rho is the density of the fluid. Okay. So, if I know the Q value and I know this value, I can find out AV, and if I know the AV, then I can use the chart to find out the size of the valve. Then example of fluid control system. Okay. In the fluid control system, suppose I want to control the level of water in this tank. Okay. So, I put a sensor, okay, and this sensor signal is sent to the signal conditioning unit, and this then sent to the current to the pressure converter, and then pressure converter current to pressure converter output is the pressure, and that controls the flow control valve, and that valve opening and closing of the flow control valve, and that way the level of water in this tank can be maintained constant. The current to pressure converter could look something like this. You have the current input here, okay, there is a pivot and there are a spring here and there is a flapper here. Okay. So, you could have a restriction here, you supply a pressure through a restriction, okay, and based on the gap over here which is maintained with the help of the current input here, you could have the pressure signal, okay, and this signal can be used here to control the flow. There are rotary actuators basically, okay. So, they are nothing but you have a cylinder and piston arrangement, and this cylinder your piston could be used to drive some lever over here. So, this way we are converting this piston motion into your this thing rotary motion, okay. Then we could have a various vane type semi rotary actuator. A pressure difference between the two ports causes the vane to rotate, and the shaft rotation is measure of the pressure difference, okay, and depending on the pressure. So, vane can be rotated clockwise or anti-clockwise. So, essentially it has got a clockwise port and anti-clockwise port, and there is a vane. Okay. So, this is the vane type of semi actuator, vane type of rotary actuator. and vane motor is used for rotation through if we are looking for rotation more than 360 degree, and in this eccentric rotor has slots in which the vanes are forced outward against the wall of the cylinder. So, here you can see that these are the vanes, okay, and these are forced across the wall of the cylinder, okay. And again here you have the clockwise port, you have the anti-clockwise port, and here these are the vanes are there, and you have the exhaust here, okay. So, the vanes divide actually this chamber into the different compartments, which increase in size from the inlet to the outlet port, and the air entering such a compartment exerts a force on the vane and causes the rotor to rotate. If you want to read more and get further details, you can refer to the mechatronics by Bolton for the further reading. Okay. So, thank you.